Hi, my name is Mike Bush, and I'm with Rockwell Automation. I'm a security technology manager within the control of the CAT organization, the Common Architecture and Technology Organization. And I'm going to spend a few minutes with you talking about how we're going to secure Ethernet IP. We have been working on this defense in depth model for a number of years now. It's still a good model. We still advocate that people build rings of security or build defense in depth into their solutions. It's still a good idea. But now what we'd like to do is say that we would like to move towards the device itself and start to harden the device. So at the center of this picture, you see the device itself. The idea here is that the security researchers have been for several years studying and researching the industrial protocols such as Ethernet IP, Profinet, and Modbus, and they've identified the fact that those protocols themselves lack security properties necessary to make them secure. And so the plan here for Rockwell Automation is to extend Ethernet IP as we know it to include the security properties that will allow devices to actually defend themselves. So in the center of our onion model here, we've got the devices. So the plan is to get to a point where they can actually defend themselves. So how is that going to work? So the plan now is to actually utilize some open standard technology that comes from the internet. So when you open up your browser and you connect to your bank website, you end up with a lock on the browser window. And if you look at that lock, what happens is that that's using what's called transport layer security. So what we're going to do is we're going to adapt the same technology that secures the internet to allow you to secure Ethernet IP. So we're going to run Ethernet IP over TLS, which is an open industry standard, and DTLS for I/O. So TLS would support Ethernet IP messaging traffic, and DTLS, which is a similar technology, again an open standard, will allow you to secure the Ethernet IP I/O traffic. So we'll have security on messaging and security on I/O, but we're not changing Ethernet IP protocol at all. We're basically just wrapping it in a secure wrapper in the same way that the internet wraps HTTP to make HTTPS. So how are we going to do that? What's going to happen is that all of the devices that get secured are going to get digital identities or secure device identities, and they will use digital certificates for that, just like the internet uses. The concept here is to provide all devices with cryptographically secure identities or digital certificates. Then the device authentication or the TLS protocol actually exchanges those credentials. And so when two devices start to talk, a controller talks to a drive, it will offer its credentials to the drive will offer its credentials back to the controller. They'll look at those credentials and say, yes, I trust the drive will look at the credentials for the controller and say, yes, I trust the controller, and they will then communicate in a trustworthy way and in a secure way, okay? So that's how device identity and device authority. The other thing that happens is once the communications has started, every single frame of information that goes on the wire has another check on it to make sure that after the communication started between the controller and the drive, for example, somebody didn't insert themselves in the middle of that chain and tamper with the bits on the wire. So using this data integrity capability, or what's called an HMAC, on that frame, what happens is that every single frame that's sent on the wire is protected. Okay? And then in addition to that, if the content is secret, so let's say that you're trying to download a recipe and you don't want anybody to ever see that on the wire, you would then turn encryption on, which is what we call data confidentiality. So what happens now is that I'll open up communications between trusted devices. I will then authenticate those devices are truly trusted, and I can then encrypt the data to make sure that that data remains secret. Those are the security properties that the industrial automation protocols have lacked for many, many years. Okay? Now, that turns out to be a significant management issue in terms of configuration. So the plan for us is to actually have a central authority that you can see in this picture here. We would have a central authority that would manage all of these identities. So what would happen is a user would interact with a central authority that central authority would then manage all of these user credentials. So all the things that I just talked about in the previous slide, the secure identities, et cetera, would all be managed by a central server. So that central server would take responsibility for making sure that all of the devices get their secure identities, and they also get their policies. And in this example, the policy is, who do I trust? Okay, so the way that works is a device comes online, it talks to the authority says, here's your certificate, here's the devices you trust, and then you can communicate from that point forward, okay? To make that simpler, what we've decided to do is allow you to do that in a segmented zone model, or zone and conduit model. The concept is, if you look at this picture, you've probably seen this before as part of our converged plant-wide Ethernet recommendations. This actually allows you to segment your system into zones. This is a recommendation we've been making for many, many years. Still a good policy, but the idea now is that SIP security can actually be deployed to actually enforce the zones. So the concept here is that I'll take all of the devices that need to talk to each other and I'll put them in a trusted zone 1. I'll take another set of devices and I'll put them in a trusted zone 2 and so on. Now, what happens is, once these zones get configured, all of the devices within the zone inherently trust each other. So any new device that gets added to the zone automatically is trusted in the zone. Any device that gets added to this zone is automatically trusted in that zone, et cetera. So what happens is that I've now created these segmented zones of trust. And then what happens is, if I want to be able to communicate across zone, I set up a conduit. So this notion is called a zone and conduit model. I'll set up a conduit between zones to allow them to communicate, okay? And then what happens is, if somebody tries to say, talk from here to here, it would not be allowed. So the idea is in a zone or between the zones using a conduit, okay? So how is that going to get configured? We're going to have a software package that will be shipped as part of RS Logic's 5000 Studio. You'll be able to drag the devices into the zones. You'll be able to select the zone, be able to go over to a property pane and say, I'd like to secure the zone, I'd like the devices in the zone to use certificates, and I'd like them to trust each other, and check the box, and then the deployment that I showed on the other picture happens automatically. Okay? Thanks for your time today, and stay tuned for further information.